I am Anupam. Today I am going to derive time dilation, Einstein concept of time dilation from Lorenz transformation. We have two reference frame. One is the static reference frame and another is a dynamic reference frame. The dynamic reference frame is moving with a velocity v. Okay, and now we have a space-time diagram where space is just one dimensional. I have measured. Space is three dimensional. We have x, y and z coordinate, but for the simplicity I have assumed this is one dimensional and the t is the other dimension. Okay, now let's say this movable inertial frame, once it's reached to this point, then both the clock is going to be synchronized. Okay, and now one torch is going to shine from this direction, the right hand side. Okay, so now once this frame, since it is moving with the velocity v towards the right hand side, if it is reached to this O prime point, then let's assume there is a point, arbitrary point, that is P. Okay, its coordinate is x and t with the x frame of reference and x prime and t prime with the x prime frame of reference. Now the length of this light will travel to this path. So this path is going to be c into t with the x frame of reference, and the same length will be equal to ct prime with the x prime frame of reference, because we have a famous formula, that is c, that is velocity, that is equal to distance by time. So therefore x is equal to ct. Okay, similar in the x reference frame. Similarly in the x prime reference frame, c, that is the velocity of light, that is equal to distance by time. So therefore x prime is equal to ct prime in the x prime reference frame. Now from the Galilean transformation we can understand that x is equal to x prime plus vt. So because the x prime length is this one and vt is this one, so this length equal to vt with the x reference frame, and the same length is equal to vt prime with the x prime reference frames, because the times are different. I have assumed the time is one time is t and another is t prime. So from here we have x is equal to x prime plus vt, and the same length x, and this length x prime is equal to x minus vt, because total length is x minus this length is vt, so it is x minus vt. Now the problem in Galilean transformation is, if we assume that t is equal to t prime, then if I put in this equation, if I put x prime is equal to ct prime, if I put here ct prime and x is equal to ct minus vt, okay, and so obviously if I just take t as common, ct prime, that is equal to t into c minus v. Okay, so now if in this equation if I assume t is equal to t prime, so I can put t is equal to t prime, and this thing will cancel out, so it becomes c equal to c minus v. Okay, so this equation is true if v is equal to 0, but we know that it is having a finite velocity and v is not equal to 0, so this type of equation is wrong. So clearly there is something wrong in this Galilean transformation. So let us see in the Lorenz transformation. In the Lorenz transformation, let us assume that the similar thing I am going to write, x equal to x prime plus vt prime, okay, multiplying by gamma, where the gamma is the error term. Let us assume this gamma is the error term that we made mistake here. Okay, and x prime, that is equal to x minus vt, okay, times gamma. So now if I let's assume this equation is equal to 1 and 2. Okay, now if from these two equations, if I multiply these two equations, we have x prime, that is equal to gamma squared x prime plus vt prime whole into x minus vt. Okay, now x prime, that is equal to, if I put x prime equal to ct prime and x equal to ct, from this equation I have gamma squared x prime is equal to ct prime plus vt prime into x equal to ct minus vt. Okay, so I can take common as ct prime, I can take common, and t also I can take common. So we have x prime, that is equal to gamma squared t prime into c plus v into c minus v. Now this is the formula of a plus b whole square. A plus b whole square equal to a plus b into a minus b. So if I apply that formula, we have x prime, that is equal to gamma squared t prime into c square minus v square. Okay, so now if I put t, if x equal to ct, then t equal to x by c. If x prime is equal to ct prime, then t prime equal to x prime by c. So if I put that into this equation, so let's say here I have x prime, x prime, that is equal to gamma squared x, I'm going to write x by c instead of t, and x prime by c instead of t prime into c square minus v square. Okay, now clearly x prime and x prime, these two terms will cancel out from each other. So we have gamma squared equal to c square by c square minus v square. So I am just putting this to here, this will go to denominator. So finally gamma will be 1 by root over 1 minus v square upon c square. Now let's see the property of gamma that varies from 1 to infinity. If v is close to 0, then the value of gamma close to 1. If I put v is equal to 0, this become vanishes. So 1 by 1, that is equal to 1. So gamma becomes 1. If v approaches to velocity of light, if I put v is equal to c here, so c square by c square, it will become 1. So 1 minus 1 equal to 0. Now the denominator is going to be 0. So 1 by 0, that is equal to infinity. So gamma approaches to infinity. So this is the property of gamma. Now from here, if I put from this equation, we have x, that is equal to x prime plus vt prime times gamma. Okay, now in the x prime reference frame, v, the observer, the person who is belonging to this x prime reference frame, having a velocity v, but he will not understand the velocity of v, because he will see himself as static. Because if we stand inside a train, I feel myself as static. But the person who is sitting on the platform will see I am moving with a velocity v, that is the velocity of the train. So similarly, the movable reference frame, the person who is belonging to that will feel himself as 0. So therefore, so vt is going to be 0 in his frame of reference. So I can put x is equal to x prime plus 0 times gamma. So therefore x is equal to gamma x prime, that is length contraction of Einstein equation. Okay, now if I put x is equal to ct from this equation, x is equal to ct and x prime is equal to ct prime, if I put here, then we have x is equal to ct, that is equal to gamma times ct prime, ct prime. Okay, so from here c will be cancelled out from both the side, and we have t that is equal to gamma t prime. Okay, so this is time dilation. Okay, now let's I have a piece of particle having mass as m in my this reference frame. Okay, one particle and another particle is here. So if it goes to this direction, having mass here m, okay, now m, so let's say it's having a velocity mu. Now, and in this reference frame, I will see that since this reference frame is moving with a velocity v, its momentum of that particle will be m into u plus v. Now, from the conservation of momentum, I can write here equal to, because in both the reference frame, the momentum will be same from the Newton's principle of conservation of momentum. So now, if I assume both m is same, then obviously from this equation, m is going to cancel out. So u is equal to u plus v. So again, I can see that this is not correct, because if this is true, if v is equal to 0, then it is true, but v is not equal to 0. It's this reference frame having a finite velocity, so v is not equal to 0. So this is wrong here. So somehow we have made mistake. So let's assume the mass is not equal in both the reference frame. So we have m, that is the movable mass, that is mass at remote measurement, that is equal to m0, that is mass at local in the movable reference frame, that is m0 into u plus v. Okay, now this is velocity, that is distance by time. Since length will be same in the both the reference frame, we have m is equal to, let's say the length is s by t, and here here m0 is equal to s by t prime. This is remote measurement. So now the s will cancel out from both the equation, and we can write from this time dilation, we can write t is equal to gamma t prime. So if I write here, we have m that is equal to s by gamma t prime, that is equal to m0, that is equal to s by t prime. Now this s is going to cancel out, t prime is going to cancel out, so we can write m that is equal to m0 times gamma, that is relativistic mass gain. So we can prove length contraction, time dilation and relativistic mass gain from Lorenz transformation. So that is basically the Einstein concept of theory of relativity, special relativity, that can be derived from Lorenz transformation as well. Okay, now the thing is, since gamma is since our normal life, our velocity is very less, because light velocity is very high, that is 3 into 10 to the power 8 kilometer per hour, but in normal time we have velocity is very less, let's say 30 kilometer per hour, 40 kilometer per hour, even 300 miles per hour, that is also very less compared to this high velocity. So we don't understand time dilation, because the gamma is actually 1 in such low velocity. But if we can create a spaceship or kind of spaceship which can travel very close to the velocity of light, then gamma approaches to infinity. So then we understand the time dilation. We can understand the time interval is getting longer and longer, because gamma comes to infinity. So gamma times t prime is going to be longer and longer. So this is the time interval. So time interval is going to longer and longer. So we can understand that time dilation. Okay, so we'll understand that a moving clock runs slow. A moving clock runs slow. That is time dilation. So this can be proved from Lorenz transformation also. Hope you have enjoyed this video. If you have enjoyed this video, then please put a like in the like button. If you do not like it, then put a dislike also. Okay. And if you have anything, any questions, any concern, then please put in my comment box. I will answer you. And thanks for watching. Bye.